Hello?
Sir, good afternoon, sir.
Good afternoon. Good afternoon.
Sir, shall we start the program?
Yeah, let us start.
Okay, sir. Okay, thank you. So, welcome to all of you. We are joined here for celebrating the World Nutrition Day. So, it is a part of the activity Azadi Ka Amrit Mahotsav. So, we are very much fortunate that we will listen the lecture of Dr. Sanjay Basak sir. He is a renowned scientist in ICMR National Institute of Hyderabad. So I will request to our respected director sir to give brief introduction of Dr. Sanjay sir. Sir.
Good afternoon, everyone. It's a very important day today, World Nutrition Day. You know that all over the world we celebrate it. I was just looking at some information. Yesterday in this conference in Jalgaon also, this was presented. Globally, 9.8% people are undernourished. That means they may be eating food, but their nourishment is so what is happening that they show some or other expression of nutritional deficiency. So almost 828 million people are affected by hunger. This is as per the statistics of 2021. They don't get enough food to fulfill their appetite. Another very serious issue is that globally 22% children under 5-year age are stunted growth. So you understand that that stunted growth means whatever physiological growth, brain growth is expected, that is not happening. So out of that, out of this 22% of the children who are below 5-year-old, but they are suffering from stunted growth because of various nutrition-oriented physiological disorders. 6.7% are wasted. That means they basically die. And 5.7% are overweight, and they are also incapable of doing many things. So this was discussed that almost 22% of the children below 5-year-old, if they are of stunted growth, this means they are not going to contribute much to this world. Means we cannot expect much return from them. So under this scenario, what to do with this population? Because this population does not have much relevance in terms of social contribution or in terms of contribution to the community. They are basically a burden to the entire community. And then you also know that because of COVID, many problems came up which eventually created many deficiencies. It has affected physiology to a great extent. So all these are new issues, current issues, because of which nutrition is becoming very, very important. And we all know that people are talking about balanced nutrition since
I think there might be some network issue.
Hello.
Yes, sir. Yes, sir. You are audible.
Yeah. I'm sorry. Yeah. So what I was telling that nutritional security and nutritional upliftment is very important for the society. So today we are celebrating it with a talk of Dr. Sanjay Basak. Sanjay studied like us agriculture, but then his specialization was biochemistry, and we were quite close during our student life. He was my junior. He is the batchmate of our Dr. Sujay Saha, and he specialized in biochemistry. Then he studied in very important institutions in various places. And then finally he joined that National Institute of Nutrition. You all know that National Institute of Nutrition is playing a very significant role in our country in developing nutritional standard, in developing various documents and information based on which we calculate all sort of nutritional regulations. So all nutritional regulations are based on the NIN's data, NIN's information. So Dr. Sanjay Basak is a director over there. He is also scientist. And over the years, he is doing a lot of work on various aspects of biochemical issues in relation to nutrition, in relation to various physiological issues. So today, even last time I met him 1 month back, and at that time we were discussing about the possibility of doing some collaborative study that we have Manjari medica, we have some other varieties which have lots of antioxidant property. They are expected to have various beneficial roles to our body. So whether National Institute of Nutrition can do something for us in collaboration as a complementary study. So he also expressed a lot of interest, and maybe in future we will collaborate as partner scientists with the NRCGrapes and NIN. So with this brief introduction, I request Dr. Basak, please address us. It's a very auspicious occasion that we are also organizing this as a part of the Azadi Ka Amrit Mahotsav. So our colleagues are of various disciplines. So I'm sure we are going to get a lot of new information from you. Thank you and welcome, Sanjay.
Okay, it's a wonderful introductions from Dr. Banerjee, Director NRCG, and I'm very much pleased to elaborate that importance of nutrition at the current context. I think many of the important issues actually brought into that brief introductions. I think that gives us a momentum to start with me just right away. So is that, first of all, this is a wonderful efforts by Government of India, that Azadi Ka Amrit Mahotsav, and then that as a celebration part of that, how it can improve our nutritional knowledge and then dissemination to that overall population, so that you can get more benefit, because people now trust that nutrition can do magic because of this after pandemic. And that is that something which they have some kind of life course kind of model experiment results has come out after pandemic. That's why the value of nutrition has actually tremendous as of today. And people are now really believing out of the book that yes, it can do something. So with that, I will thank you, Dr. Banerjee, and also my former colleague, Dr. Shah. Also, he was in touch with me, and many other senior colleagues of the prestigious institutes of this NRCG and other colleagues. So good afternoon, and as already briefed about that, I'm just trying to make that today's discussion in an interface so that it can be more closer to both the institutes. With that, our interest is in future, if there is a possibility of the collaboration work. And I'm just trying to find that what are the interface which can be common and overlapping. So I have chosen this area, is the nutrient antioxidants and how they're modulating the disease. So I will quickly brief about this. I may take 1 hour or 40 minutes. I will try to, I don't know how much minutes, how much hours they allow this Zoom, but I will try to make it very fast if it is possible. Okay, so is that what I'm trying to first emphasize about that the events and the progression of disease. So this, if you see this diagram, this photograph, so what is showing is that image, that there is a healthy state and there is a disease state. That means this dotted line actually depicts that actually healthy state of that which is showing in between, and in the circular dotted line, and where this over the years, if that the disease states actually comes around, and this the solid line indicates that actually different disease states, and each state can be monitored by different biomarkers. So now the question is, this development of healthy state convert to the disease states, and where the nutrition plays around, and then how much it can play around, and what is that role beyond which it can't, and where you need to help of the pharma, that means pharmaceuticals. So that's the things, if you see this curve, and nutrition has actually a major role to, at least if not can revert, but can prevent or can normalize or can manage that disease which has been detected even at this stage. So that is the major emphasis, how it can actually modulate the progression of disease. Now, if you see, for example, in case of cancer, let's say is a just example, this is an example in case of colon cancer, when it starts in this different stages, and it's showing that, and what I want to try to make it here, at what stage this nutrition or diet can have an impact on this through this antioxidant module. Now, if you see this, that this is a normal crypt. Crypt means that's kind of in-depth invasions of that kind of anatomical structure, which is initiated at the beginning of the cancer, and then it enlarged around 10 mm to that make it aberrant crypt, like it's elongated, and then make it adenoma, and that around less than 10 mm size, and up to that it promotes to that large adenoma. So, and this is the kind of molecules which actually aggravate that situation, which is just as a representation. I just kept it. If someone is more interested, you can find it. But what I try to make the message out of here is that, so if you see that interface of the diet and nutrition can be actually controlled and can be actually prevented here. So on the other way, if that is not there, let's say antioxidant fruits and vegetables, and absolutely not there with a much insult on that, then this could result on these sides. And that is also happened in this case. If you see the other problem is that other than cancer is cardiovascular disease, a massive problem. And now in the younger age, much is reported, especially after pandemic. There are many hypotheses which is beyond the scope of this discussion. But what I'm trying to show in this case, this is a kind of atherogenesis, that means plaque formation of that intima. Now, if this intima, this green color actually is a plaque. So if you see that lesion has increased over the period of time, and this is a year bar, and then when this lesion is increased, then what you are getting actually is that plaque is forming and getting condensed, and then it leads to different kind of manifestations starting from ischemic heart disease. Ischemic means there is no supply of blood and oxygen to the heart, or cerebrovascular, that means in the brain, the vascular interruptions, and then it could lead to stroke, other peripheral vascular disease with a lot of symptoms. So again, the diet has a major role to play, at least to control or delay these events. Now, okay, so what is the basic assumption is that all these things, what we are assuming, the hypothesis is that oxidizing free radicals, those are participate in the early event that actually lead to the disease. Let's say if this is that, this can be prevented by antioxidants, and therefore it can reduce the disease risk. That is the basic assumption. And so then question is, what is the evidence? And so we'll look for evidence. And before to do that, just have a quick look into that, the kind of fingerprint, like what is that actually antioxidant, how it works, the little bit on that, so that it will more clear to the, it is a state where the free radicals are generated. And if you see that from the chemical point, if when the short of one electrons, that means you have a pair with a stable atom, then loss of pair, that's an unpaired electrons. This actually is a problem. This generated free radicals. At this free radical, these are unstable. They try to have another pair of electron always. So unpaired electron actually create instability and become highly reactive. And if you see in these equations, what I'm trying to make it, this is that free radicals, and it's AH. This could be anything biomolecule like protein, lipid. So this unpaired electron try to seek another association of other unpaired electron to make it more stable, and so eventually it will actually make this cause kind of free radicals with the generates, and which can be detected through this biomolecule, not by this. So is that always the electron will be seeking for stability? Eventually, it will causes the stress in that. Okay. Now, this free radical, whatever that mediated damage is happening in these biomolecules, that could lead to many disease and developments. And if you see this manifestation of the free radicals could lead to several heart disease, chronic heart disease, cancer. So all the disease in other way is causing damage through this, actually through these pathways. Now, if you are trying to make something like antioxidants to protect this, there is no guarantee that you will be affecting these, but there is, because you are actually affecting the damaged part. So eventually, whether the damaged part will control the disease is it depends on the conditions and the patient and individuals and the state of the disease. So that should have a very clear view on it, what it can do actually. So if you see that other way to generate that free radicals is that lipid peroxidations. What it does, it actually, in case of membrane and cholesterol membrane, there is a hydrogen abstractions, means there is a transfer of hydrogens. So this is the free radicals. Once the hydrogen is transferred to the structure, it actually reorganizes. So this is the first step, that this is reorganized to the make a diene conjugate. Is an internal molecular rearrangement. Once this molecular rearrangement happens, then immediately take up oxygen and generate peroxyl radicals, and again are followed by hydrogen abstractions and release the hydroperoxide. So this cycles is a VCS and can goes around and around and generate severe even free radicals causes the disease. Now it can also do at the level of DNA. So it can cause free radical attack on the damage to the DNA. So DNA damage is very much obvious in the cancer, many of them. And once it's the damage done because of the failure of this repair mechanisms, then they replicates and subsequently incorporate. It could be due to the mutation as well. So, but the question is, how do we measure the free radicals directly? It's very difficult because we have to rely the biomolecule which actually attach to the free radicals. So it's indirectly you are measuring. But at the same time, you have to consider many confounding factors. Let's say if that the left side will try to make some assays which can measure the free radicals, T-verse and thiobiouritic, that you can use this, we can say lipid peroxidation, but the confounding factors could be iron. Why? Because iron, again, has two forms, heme and non-heme. So when you have the heme, and that means is from the protein from the red meat and other sources. These are actually causing oxidative stress in excess amounts, and whereas the non-heme part actually protect that oxidative stress. So then it may have a confounding factors when you're measuring through T-verse. Again, bilirubin also actually antioxidant, endogenous antioxidant for the liver, and that so it can influence your value for the T-verse. Then you can list it that conjugated dienes, and then dienes of those can interfere the dienes from dietary origins, hydrocarbons. This can comes from pollutants, and many even the fat stores also. Lipid peroxidase, and this is very much there in the protein and hemoglobin. Their value can influence that. Then you have a protein carbonyl, it could be dietary origin. Then F2 isoprotein. Actually, this is the gold standard used for measuring oxidative stress in the body. And then problem is this is very complex to measure, because if someone has a huge amount of red meat intake or maybe inactive lifestyle or smoking, then their endogenous level will be always high. So it will be difficult to measure the appropriate field interventions, which when you want to measure the antioxidant potential about that. Then other is 8-oxo-DG, and this compound actually is again has been used for synthetic, has been used for this measuring that endogenous oxidative DNA damage. Yes, for measuring the cancer incidence, but there could be some kind of artifacts in the oxidation of DNA endogenously. So this can also influence. So this is the factors which is difficult to measure when you wanted to have this free radical to assess that potential of the antioxidants. Now, what are the sources, endogenous sources of these free radicals? It's we know that mitochondria is that something which generate ATP, but it at the same time is also produces this superoxide, and this is almost it contributes 1 to 2% of the oxygen used by the respiratory chain that ends up with superoxide, but it's very less so. But we have to consider that also. Then superoxide is actually detected in vivo, and apparently they are okay. I mean, not so reactive, but it drives the Fenton reaction. That means whenever there is oxidative situations and oxidative stress, like hydrogen peroxide and other, then generate these hydroxyl radicals. And this is something that contribute to the oxidative damage to the living cells. So in that way, it is actually danger, superoxide. So these are the favoring the conditions of that. Naturally, it can be found in mitochondria, endoplasmic reticulums, and another way. So now there are many numerous pathways that generate a loss-reactive oxygen species, and then radical pathway, name it, superoxide, hydroxyl, peroxide, coaxide, and then non-radical hydrogen peroxide. And this is just to show you that the different kind of, when you're dealing with the ROS system in that system. Now, then we have to also consider that to the pollutions, then UV radiations, and energy intake is the high-fat diet. Then it has a mitochondrial ROS generations, and then with the high calorie. So this also comes from that ROS generations. And obviously, smoking is a known risk factors for the polycyclic hydrocarbons, is saying that's from the smoke order. So these are the exogenous source of free radical we generate. Now, thing is that if we know that this is the free radical which we are exposing there endogenously or exogenously, then why we are not going rancid, like with oil gets oxidized to that and get rancid, but we are not becoming rancid all of a sudden, okay? Because we have a very complex integrated antioxidant defense systems, and that is endogenous antioxidant. And I will be talking about both endogenous, is that, and as well as some of the phytochemicals which will actually impacting that endogenous antioxidant system that improve that antioxidant system. So some of them we have synthesized, but we need from the diet. So that is that. Now, if you just see that these are the important things I just listed, but I mean, it's very difficult to consolidate all within a short period. But the major, if you see that left side, is a selenium, iron, copper, zinc, manganese, and they are the actually metal cofactor of these various antioxidant enzymes, whether it's a glutathione peroxidase or catalase or superoxide dismutase. So they are part of it. And again, antioxidant compounds is a source of vitamin E, which is a fat-soluble vitamin. I will be talking about that. Carotenoids, vitamin C, polyphenols. So I will be talking about polyphenols. So let's see how it can happen actually. Now, to start with that, from the food technological perspective, as a food technologist, when they define antioxidant, their definitions are not similar with the biological antioxidants. What they define is the substance that they use to preserve food by retarding deteriorations, rancidity, and discoloration due to oxidations. So what is the requirement is they should have a low toxicity, no color, odor, flavor, effective in low concentrations, easy to incorporate, survive. Processing, so there will be a lot of food processing, and then good carry-throughs, and obviously the cost is very important in any product. So these are the criteria attributes they're looking for antioxidant food technologies they use in this food industry, and that means synthetic antioxidants. So that it's important to understand the synthetic antioxidant. Then it will be easier to work on that. Actually, the antioxidant which you will be dealing with is natural source. So how they work actually. Then I just put at a level of different kind of antioxidant we use in the products. So synthetic antioxidant. Then this is anisole, and this is toluene, then gallate, and then I think tertiary beta hydroquinone. And their presence are there in the different kind of foods, and especially these are mostly on oil and fatty foods. They're used. These are all cosmetic industry, and they're all food industry also use this different kind of synthetic antioxidant. So biologist perspective, the nutritionist perspective, the compound that protect biological system against the potentially harmful effects of the processing or reaction that can cause excessive oxidation. So is that very simple way that it must be absorbed to the intestines. This is one first criteria if you wanted to claim that my product is antioxidants, and then it should be transported to the site of actions for the functions which we are looking for, and it must be low in toxic. So these three criteria is attributed for the biological antioxidant. So basically the three different ways that biological antioxidant work. First is they scavenge the free radicals, and second is that they bind to the metal to prevent the Fenton reactions, which I showed you earlier, that generate hydroxy radicals, and that's very dangerous for causing oxidative stress. And then third is upregulating the antioxidant enzymes, which I showed. So this is the three major way this biological antioxidant work. And what I'm trying to show in these slides is that you see these antioxidant enzymes, and this is the state of free radicals generated. So actually, this balance when it got over, like means is imbalance of this leads to oxidative stress and damage to biomolecules, and manifestations. Several diseases have this kind of imbalance. So it is the common pathway. Somewhere this happens in this disease states, in this imbalance. Okay, so now how they do work actually, the scavenging? If you see the scavenging, which was the first strategy of antioxidant work, they actually, what they do is they come to that free radical, they make it a form, which is they're removing that hydroxy and make it more inactive quinone, like in the inactive forms, which essentially give you somewhere is that stable to that molecule, and that is the way they want it. Antioxidant does it actually. And then other way, as I told, that it can bind to the different kind of metals as a cofactors, which is important for the enzymes, for the antioxidant enzymes, which actually mitigate that kind of oxidative stress and then stop Fenton reactions. Now, so these are the antioxidant enzymes, and as everybody we are aware of it, that this superoxide dismutase or glutathione peroxidase, or you see catalase, that these three are cited here mostly, and they're predominant these antioxidants to catabolize this free radicals. Okay, so I just wanted to have one short quick data about that, how this that kind of antioxidant which we talk about, that fruits and eats plenty of fruits and vegetables which contains antioxidants. We talk about every day. So what the data suggests, if you look into the epidemiological data here, this graph, if you focus here, there are two different lines. One is this directions, is the square shape, it goes up. And this is the fruits and vegetable availability across the countries globally. Okay, and this side is another curve, another line, which is actually the death rates from that ischemia heart disease from 0 to 64 years. And so how it plays around, if you see that when there is the availability of fruits and vegetables goes up, their death rate for the IHD across this country comes down. So there is a clear-cut benefit from the epidemiological data, that importance of antioxidants, which is predominantly there in fruits and vegetables. And look for this, obviously this is cardiovascular, and again for the cancer study, if you take that where it is showing that odd ratio, and especially if you see that odd ratio of the different kind of cancer, and that means there's a risk, which as with the more, if you are not taking up these fruits and adequate fruits and vegetables, how to interpret then that if you see the stomach is far away from this normal line, that means there is an incidence of stomach cancer will be more if you do not have this kind of fruits and vegetables in other way. So compared to the other cancer, which is not directly related to the per se metabolisms. So in that way, this is also that tells about that importance of fruits and vegetables in a way that antioxidant. Okay, so once we talk about the antioxidants, and so we also come out to that these phytochemicals means plant containing chemicals. It's phytoprotectants and plant bioactive. There are many, there are plenty of synonyms, and what they are actually, what they do in the plant is basically for the benefit of the plant, they are there in the plant, but we want our benefit from them. So that is something which is, but actually what they do in the plant, they provide this kind of, support for the plant in terms of pollination, color, then leaf, flower, growth, development of the plants, then obviously disease, pathogen, and other resistance their own way. But what we are looking for them is for our own benefit is, so because of the fact that the studies are accumulating over the years that these phytochemicals are actually at a different level, it can protect this kind of, in terms of as anti-cancer agent, like it can inhibit the metabolic activation of carcinogen, or it can stop that initiation of the interactions of the carcinogen and DNA, or it can delay the promotions of the multiplication, eventually tumor growth. So there are multiple ways there are a lot of literatures is available on that supporting that different kind of events which is protecting these phytochemicals. Okay, so if you take about that the mechanism for that, how they inhibit, say, for example, if you some sulfur-containing glucosinolates or phenolics, that induce the phase 2 detoxification mechanisms. And again, they inhibit the initiation of some of the phenolic, they prevent the oxidative damage to the DNA and promote DNA repair mechanisms. So in other way, it improves that endogenous mechanism, repair mechanism. And then some of them are actually phenolics and colloids show that they promote apoptosis of that particular affected cells. So this different way it works actually. So similarly, these phytochemicals also are having several cardioprotective effects, and at a different level that it can damage, blocks, delay the damage of the arterial endothelium or oxidation of is LDL, that means lipoprotein, low density lipoprotein, which is a risk factor for cardiac disease. Then it can also block the macrophage activity or oxidize LDL, and then another, and can it can prevent that monocyte adherence and platelet activations, which I will come into later about the platelet issues to a clear-cut case examples. And eventually, it can actually modulate the coagulation systems in case of platelet aggregations, which is very hyperactive in some disease states, and eventually caused a heart attack and cardiac manifestations. Okay, so this is again some of the examples where the polyphenols or phytochemical works is that, and for example, this terpenoid acts as an antioxidant by binding iron or directly scavenging the oxygen species, and by thereby prevent that oxidation of LDL. Then you have taken some sulfur compounds, few sulfur modulate chemotactic factors by affecting the prostanoid productions to improve that. And then again, it inhibits the platelet and vasodilations. So then phenolics and alkaloids and sulfur compounds that inhibit COX-1. Remember, this is the COX-1, which is actually aspirin does the inhibition of the COX-1, which this phenolics, this also phytochemicals also do the similar effects. I think that much potential these phytochemicals have this. Okay. Now, so overall, if you can make it that a statement that these are the phytochemicals in the compound actually are not recognized as a nutrient. And these are not the essential dietary factors such as vitamin, mineral, amino acid fat. No, it is not categorized. And there is no deficiency syndrome because it's we are using it. But it can modulate these health functions. So that as a primary care is not that. That's why it is very important for the researcher interest to develop that. So the general overview, I will quickly go through this because I don't think I need to elaborate this if you are aware of it. Just for the quick, that different kind of phytochemicals that constitute the terpenoid, alkaloid, sulfur compound, or phenolic polyphenols. And these are some of the carotenoids and plant sterols, and which you can find from the tomato, peas, citrus, fruits. And there were several functions. It is already established that then you have alkaloids, and that actually mostly the capsaicin. Some of them are important, and then caffeine and other, and they also use for different kind of prescription drug in that, and also historically they use as a poison in some cases. Then you have a sulfur compounds, and then is an unpleasant taste, and it's onion, and then you have that brassicas. All this is rich with that. Then more interesting that people have shown a lot of interest on that because there's a large kind of effects on health benefit effects that are actually showing that. And so some of them I will just, so what is that? They have a different secondary metabolites. They metabolize to different kind of compounds, series of compounds, these phenolics pathways, and some of them are already worked in various stages in the different kind of functionals. And obviously one is the highlight is the flavonoids, which is very much highlighted for their many functional benefit. So if you see there's a flavonoids, cinnamic acid, so different kind of phenolics, and their source in the foods. And what I mean to say here, these are also associated with the different kind of glucose molecules, sugar. So, and this level of phenolics depends and varies of the species, variety, light sensitivity, ripeness, processing, storage. So different factors modulate of this phenolics level in this kind of substances, which we can use as a phytochemicals. But the thing is that if someone wants to use as antioxidants, you have to consider that it has been associated with the glucose. So important to have this, whether you need to carry or you need to remove that part to get the greater effect on the phenolic is a big question when you're designing antioxidant. Okay, there are a few well-known phenolics, phytoestrogen, salicylic acids. Then the isoflavones, if you see that soya is mostly rich with isoflavones, and they have several benefits on that, especially on steroid metabolisms, osteoporosis, osteoarthritis. Then because they have a structural similarity to the ostradiol. And then you have a phytoestrogen C, so as I told you, modulates that steroid metabolisms, and there are the potential, maybe they are alter the growth proliferation of hormone-dependent cancer cells, but it's not very much clear, but a lot of ambiguous, and they are possibly modulated osteoporosis, and thought that it can lower the phytoestrogen in soy blood cholesterol level. And some of the data are demonstrated they might have a contribute in the protective against the coronary heart disease. Okay, so many phenolics are the good electron donors. So what I mean to say is how this phenol works as antioxidants. So if someone, so is the message is if you are a donor, you could be a good person actually. So these phenolics actually, it donates electrons, and so they become more potent in terms of reducing disease. So just I'm giving one small example here, the comparative data, if you see all the phenolics as compared to the vitamin E and the vitamins. And what the data is reflecting here, this is galvanoxyl reductions, which is used at a scavenger systems. They use that, it's a probe to use how much is the reductions of that, free radical scavenger, ability of the reducing the free radical scavenging, their potential is probed by this assay, this galvanoxyl reduction. And if you see if the red and blue for each compound, that means this is how much is there that they reduce. But if you see that compared to vitamin E, there are these vitamin E that's much more beta than this vitamin E. And so the reduction is much more in terms of potential of as antioxidants. So this is something gives us, then the question is whether the antioxidants are also there in the biological systems, whether there's a lot of data are there coming up that they're protecting at different level, that so mitigating that free radicals, stopping the free radical oxidative stress, and many. On the heart disease, cancer, you'll find epidemiological data from the experimental cell culture, but you won't find much intervention study that directly where antioxidants have been used and then get as that some kind of things, because it's a very complicated is that as an antioxidant when you use as an independent way. So I'm not going to this kind of detail of the study, but that as I told you, what is that antioxidant? If someone wants to have the biological antioxidant, 3 criteria should be there: that it should be absorbed to the intestines, transported to the site of action, and low toxicity. Now, this is that what I am trying to find. One data I just wanted to show you the polyphenols, label polyphenols, and how they are present in the liver after different time points. Once you label with the polyphenol ingested, then you are detecting the liver tissue over the period of time. Then you find that 30 minutes, your count is around 60,000, come to 10,000 within 300 minutes of 5 hours. So there's a rapid removal of liver. So the problem is then bioavailability. So it will be clear much faster. So where it is not the intestines, you need the larger. Then another thing is that it forms several numerous secondary metabolites, which you are not meant for that. That means you got some different kind of metabolites which we have not intended. It could have a beneficial effects, but we have to test individually. So if you see that what this animal experiment, what this the bioavailability of the polyphenols and others is that there's only 2% of the parent compound in the intestines. So it is no parent compound found in the non-intestinal tissues. And then if you see, the other problem is that these are actually converted to different forms of different metabolites. It's methylated, sulphylated. So it transfers to the kind of metabolites which is not intended for the purpose. So that again is a difficulty in designing that kind of, So what is the science point is that some of the polyphenols have a very low bioavailability and some are rapidly metabolized with response to xenobiotics. And methylation, glucuronation, sulfation is likely to reduce the antioxidant potential. Yes, obvious, because it was not intended. But metabolites may have other bioactive. We have to test that. So that's why that other phytocol may be salicylates and other. But we need to be tested then. So one of the important, antioxidant is vitamin E, which is also popularly known as tocopherol. So I'll quickly have a few important things about that vitamin E. And then this is, it's a lipid soluble. So whenever we ingested lipid and food, this comes with this vitamin E and all these lipid soluble vitamins. And it's the main source is plant oil, nuts, and it prevents the lipid peroxidations. So if you see that the tocopherols and tocotrienols all together, it calls as a tocochromones. It's a vitamin E. And then, this are only, there is a different isoforms, alpha, beta, gamma, but alpha is the only active forms. And this is very selective in our systems, it's selectively used at alpha. So alpha tocopherol and alpha tocotrienol is the only active form in the tissue. And so if you see that how vitamin E works, and it actually, this is active form. This I'm showing that lipid bilayer where this tocopherol interfere and then stop oxidation of a membrane lipids. So that's why it protects that. And this alpha tocopherol is as an antioxidant. And deficiency is very rare in humans, some reported in cystic fibrosis, premature infants, but animals it's more prevalent. There is a requirement, and obviously it can withstand that. Deficiency is not there much, so it has a large acceptability on the safer doses range. And then if you see just here, these two different oil and different kind of vitamin E. So alpha tocopherol is the predominant one, but if you see that soybean oil are reaching this gamma tocopherol, which may not be actually interested and not be active one. Similar also here, tocotrienol also contains these oils also contain tocotrienol, gamma tocotrienol, palm oils compared to the other oils. So just give an example about that, but they are also enriched with tocotrienols, so high, which is very active and provide antioxidant effects. Now, the question is why alpha tocopherol is the very, important one. So if you see these diagrams, so intestines takes about this, once it is ingested, this vitamin E, and that goes to the chylomicron and the remnants after breakdown of the lipoprotein lipase. Then both gamma and alpha goes to the liver, but somewhere liver, this is tocopherol binding protein. They are very selective that they push this gamma tocopherol to the biles and then select that only alpha form to incorporate in the VLDLs, and then it incorporates the other tissues. So this selection is natural. So we have it is being there. So one other way, that's why this is due to the selective nature of the liver to choose our particular isomers. This alpha form is mostly predominant in the tissues. So then ones need to be considered when we consider about the antioxidant, which is the predominant forms, which is effective in this as a vitamin E, if you need to choose that, develop that any antioxidant. So here, just the same data which we're trying to show here, after replenishes in a different kind of tissues, if you replenish with tocopherol with two different kind, like alpha is a yellow color and green is a gamma tocopherol. So how their presence in different tissues, with the liver, with the heart, with the kidney, with the brain, you see the yellow is that maximum. So the point is, okay, soy oil is rich with gamma tocopherol, which is unintended. Yes, it is true. That the point is that just to make a point about that, where the gamma tocopherols is predominant is one of them at least. Now, before I wind up this discussion today, so I just wanted to have one case study about the cardioprotective factors from the fruits. And this has been my personal data personal experience with these systems and my work. Some of them I worked in that during my training. So I just want to have a quick about that. The cardioprotective means once you need to make that, this major emphasis is that cardiovascular disease, and one of them, cardiovascular disease, is called that blood coagulations. That means platelet hyperactivity, and platelet hyperactivity is a manifestation of cardiovascular disease. And then this platelet hyperactivity or aggregates during that cardiac arrest. And so people around the world is looking for alternate to aspirin, which is used as a blood thinner, and which has used as a this antiplatelet aggregators from the natural sources. So to know about that little bit, one concept on that, how platelets, what is the role of the platelet in the blood vessel is a, platelet, three different stages are showing. Actually, platelet activations in the blood vessels has a three manifestations, and where each actually platelet major role is when you cut in our body. So it means when there is a discontinuity in the blood vessels, then platelet come to the picture. And how? If there is a discontinuity or the vessel injury, you have these platelets which get activated, and along with that, you have several other G proteins which coagulating factors helps to activate. And then once there's a discontinuity, and then this comes into the activate, it's a three-step process. Once it is activations, then adhesions. So most of the adhesions molecules come into the effects and recruit those activated platelet into the site of injury, and then they form a hemostatic plaque, like aggregations. Hemostatic means is a stop of the blood. Like blood, when you cut, blood flows need to be stopped, hemostatic plaque. So they use these aggregations used as a natural defense mechanisms for stopping the blood flow and use as a platelet. But this hyperactivity is also there in the disease state. So it is important to understand the physiological stage of this platelet functions to know the disease. And if you see this more visually, how this works, if you little bit closer look onto that, this kind of different kind of cells, these are the endothelial cells, and these are the resting platelet, and these are adherent platelet. And this is the activated platelet, and these are aggregated platelets, which is actually, if more aggregation means your normal blood flow will be interrupted, which is being happened. The plaque formations and others during the cardiac arrest. So this is all about the event which actually platelet already plays a role, and what I'm trying to put kind of points where these are some of the facts, some of the functions of the platelet already established, and some of them are going up, like research is coming up in the different areas. So that's the things which I wanted to show you in this slide. Okay, so these are the hyperactive platelet. Those are associated with different disease states, as I told you. So platelets become hyperactive and produce microaggregate in clinically defined conditions in that hyperactive state. And so different kind of, hyperactivity is manifestation is several diseases. Not only that, it also secretes some other pro-inflammatory markers or immune cells that further aggravate the situations. Now, if you see that activations pathway in the closure loop, is that this is the circular is the platelet, and these are the agonists or inducers. That means collagen, then ADP, adrenalines, and this inducer, what they activate the platelet. Once it activates, what it does is this further, this adhesions, it goes to the site, as I showed you previously, that it recruited these growth factors to make this some kind of, because platelets are very sticky. So they wanted to make an attachment to that particular injury sites. And then these receptors of this G protein receptors, with coagulant receptors, and they become activated. Once it activated, then thrombin come into the picture, and this thrombin release and then produce, and then coagulations happens, and then it gets, aggregate on the platelets. And if you see that where the platelet hyperactivity and the drug which is used for against the platelet hyperactivity globally, everybody knows it, aspirin is used as a blood thinner. But FDA does not recommend that the general use of aspirin for primary prevention or as a heart attack or scope. So you have enough scope to explore something which have the primary, can take a primary care of these, aggregations. Usually, if you see that aspirin where it works is all this inducer of this, so stimulate this arachidonic acid pathway and a lot of pro-inflammatory like oxygen, and that induce the thromboxanes, and that thromboxane actually activate this fibrinogen receptors. What it does, aspirin, it blocks this pathway, and thereby it keeps the blood thin, so it does not give the tendency to clot each other. But it cannot prevent the thrombin. You see this line. So still, it allows the thrombin-induced, inhibitions. Okay, so here I'm showing some data where the lab where I worked actually, and what they have found interestingly, they need to understand that this experiment has been set up. Different kind of fruits extract they use, and in the left side, which is showing, and then ADP as an inducer or agonist, they used as to mimic that platelet hyperactivity, and then this fruit extract has been used to see how much it can inhibit. And if you see the percentage of inhibitions across the fruits, tomato is the highest, 89%, followed by this kiwi fruit, grapefruits. So this gives an idea that this has something, it has rich chemicals, some phytochemicals, which is causing this. And then further, if you see the different aspects of platelet functions, when you have other agonists, let's say I have already shown that different kind of agonist. When you created that, what this experiment, what the data is showing is that the blood was taken, that means PRP. This is platelet-rich plasma. How? From the blood, from the subject, from the human. When you take the blood and immediately spin down, you have a 55%. On top of it, you will find the liquid, and then the rest of this is very dark, and other is little bit less color. That is called platelet-rich plasma. And that has been recently came, is very important because it's rich in growth factor, is used in allotherapy, and a lot of things people are using that. Now that PRP has been used to induce with a different kind of agonist. And then after induction of this agonist, tomato extracts compared with aspirin and with a difference. And percentage of inhibition is shown. And if you see the percentage of inhibition, in each case, for example, in case of tomato extract, ADP induced aggregations inhibited 66%, collagen induced is inhibited 45%, arachidonic acid induces 25%, and thrombin 67%. And where the aspirin is much lesser than that. And moreover, it has no effect because, as I already showed, that thrombin is still cannot protect these aspirin aspects. So as a primary care, it has a more potential showing that. So their discovery, what they do, then they measure that bioactive where actually what they are thinking that somewhere in this region that's mostly concentrated in that what is called, I think, locular or some gel area. So what I'm not exactly, it's a locular gel, I think they call it. I'm not sure about that. So, but what they found is after doing HPLC, there are many presence of high water soluble compounds, mainly nucleosides, highly active, but less predominant of the water soluble compound those are highly active in the thrombin-induced platelet aggregation. So they are coming out that kind of more aggregate investigation on that clinical trial and other, so which beyond the scope of this today's meeting. So to summarize the whole point, which I'm trying to make it here today. So reactive oxygen species, that in ROS-mediated oxidation of biomolecules, which has been implicated in many diseases, and a sophisticated antioxidant defense systems, which I discuss it in many examples, that should minimize the oxidation. And some antioxidants are required from the diet, like for example, trace metal and micronutrients as vitamin E, vitamin C. And nutritional antioxidants are very essential for our maintaining our health and protecting from disease. So evidence from the benefit of high doses in preventing heart disease and cancer still yet to establish conclusively. And oxidative stress is related to aging. So but antioxidant capacity is not. That means individual lifestyle, food habits actually matters when you have antioxidant, but oxidative stress eventually bound to happen to everyone when we are going for aging. So it's important that you don't megadose of any of these things. So with that, I will try to conclude and leave into that discussions, and if you have any questions, and with that further, so that I'll be happy to share. And with that message, it's important to bring us back to that when we are doing research on antioxidants, we should also follow this practice in our life as a nutrition as a whole, and some of the back to the basic and practice in our daily life. So with that, I will conclude here, and it's open for discussions, and I'll be happy to any questions and comments and suggestions on that. Thank you.
Thank you, sir. Your presentation is really very nice, very informative. So many things have been covered here, right from your free radicals, antioxidants, alkaloids, all these things. As we are the scientists of agriculture, so many things we know, but we don't have knowledge in details, how there is a relation of the radicals and all these things with biomolecules. So, sir, it's a very informative presentation. And now I will say that the topic is open for discussion. If anybody have any doubts, any questions, they can ask to Dr. Basak, sir. Sir, I have one query.
Yeah.
As you told that synthetic antioxidants. Suppose nowadays so many ready-made foods are in the markets, and suppose there is a more consumption of this food, and synthetic antioxidants are more in the body. So what will be its drawback?
In a normal person, for a normal person, or you mean to say disease person?
Sir, you can say in both conditions, sir.
Okay, so synthetic antioxidants, when you come to have the picture, when you wanted to use synthetic antioxidants, you are actually making overprotection of something. So first of all, that mostly processed food, which are mostly use these synthetic antioxidants majorly because they wanted to keep the shelf life of the particular food. So in other way, while we are not much encouraging that processed food in our daily life, that's why I showed in the last slide the whole grain. So the grain, which back to the basic, which we are trying to say, that what we are trying to have this in our daily life. So it's important definitely to select that. And if someone has a concern about that too many synthetic antioxidant has been used, this is a really concern. It could be have a concern for that because antioxidant overdose, as I told you, is also not a good idea actually.
Thank you, sir. Thank you. Any questions? Nishan, sir.
Good afternoon, Sanjay sir.
Namaste.
Namaste. Nice to meet you after Hyderabad.
Yeah.
Yeah.
Nice.
Yeah, sir. I would like to know about the UV radiation and antioxidant potentials. What is this relation?
Actually, basically, it's causing DNA damage. If you see that DNA damage means, especially in some of the country like Australia, when what I came to know about that, depends on the melatonin, like of the skin, are susceptible for these UV radiations. In addition to that, antioxidants and other, but it's more about DNA damage because of this imbalance in that hormone which is under the skin due to the skin color, and UV radiations causes cancer in that cases through DNA damage in that susceptible people. Those are having that, especially the many reports in Australia, skin cancer coming through that, but the mechanism involves DNA damage.
Hello, sir.
Again, I would, Dhananjay, please.
No, please.
Sir, do you have any idea about production practices we followed for production of tomato, any vegetables and fruits? Production practices for production of any fruits. We produce fruit in the field, and if tomato is produced under acidic soils, has any response to get with nutritional balance in others?
I'm not very clear about the questions. You mean to say soil condition influence the nutrition parameter?
Yes.
Yeah, it is there. It could be, because definitely. One slide I was showing that this level actually varies different factors, including variety, light sensitivity, ripening stage, processing, soil, biotic and abiotic. Both factors are influencing actually this antioxidant level. Certainly, we need to try that. Need to measure that level.
Thank you, sir.
Okay.
Hello, sir. This is
Yes.
Dhananjay from NRCGrapes. Sir,
Yeah.
I want to know about you comment on the aspirin during cardiac arrest. Why it is not recommended? Because it is readily available in a difficult situation. Still, it is not recommended.
Which
Why
one?
it is- Aspirin.
Ah,
You told that aspirin is not recommended during cardiac arrest.
No. Aspirin is not. I think you misread that statement. Aspirin is not recommended as a primary prevention of the cardiovascular disease. Once a disease is detected, then only gives aspirin patient.
Okay.
I think you misread that point. What I mean to say is, if someone wants to protect or prevent that cardiovascular disease or events associated with that cardiovascular, let's say platelet hyperactivity, another state, so you can have this primary, not aspirin. You cannot take aspirin, correct? I cannot take aspirin for prevention of the cardiovascular disease, but I can take antioxidants naturally. That's the point why I'm trying to make.
Okay. Thank you.
Sir, good evening, sir.
Yes.
Dr. Shabir from NRCGrapes.
Nice to meet you.
Sir, here we have extracted a grape seed oil from a particular variety, which is found to be very high in vitamin E, especially the tocotrienol, gamma tocotrienol, not tocopherol, gamma tocotrienol. So, in your opinion, what is the advantage of tocotrienol compared to tocopherol? It is beneficial compared to other seed oil, or it is seed oil where the tocopherol is higher concentration compared to tocotrienol. So which vitamin E component is more?
I got your point. Actually, if you see, there is a two interface. One is, as I just try to told both the interface. One is antioxidant, which is remain in the plants for the defense purpose. And other is antioxidant endogenous, like our systems. I talk about both. Now, what I told you and what is already established, that alpha forms of tocopherol actually is integrated in our tissues, and liver is very selective. Now, if you have some oils which is rich in gamma, so there is no harm that it cannot be used for the purpose which is may not be directly relevant to the human consumption. So you have a right, because still this has a protection. You have a enriched with vitamin E. So try to use that functions, that antioxidant functions, where it works much, where is the applied. So this is, it depends on, you need to design your applications of the particular compounds or the oil where you wanted to make it.
Okay. Sir, another query is most of these polyphenols which is present in plant origin are soluble in water. Water soluble mostly. So their main issue which we understand is bioavailability for inside the body. So most of this goes through excretion. So in your opinion, what strategy we can adopt to improve its bioavailability other than its efficacy? In vitro efficacy it will be there, but in the real body it is not available for the body since it is water soluble most of the cases.
Yeah, improving the bioavailability is a really issue with the polyphenols. It is being established already, and it is being already there. What people are using some carrier, and so they are adjoining some carrier, some of them which has a lot of retention in the circulatory systems, some organic carrier, or some people use nano carrier, but again toxicity would be the issue.
Yeah.
So then if you can design some kind of carrier natural source, I think then it may have a good improve that availability, or is go for combinations. Then you need to test it with the combinations for the safety.
As far as human body is concerned, which pH will be the ideal one to get the more available?
For
Which pH of the media will be more ideal to get more available to the body?
No. Anything you take from in our body is we do not take the food based on the bioavailability.
Yeah.
Correct? We take the food always which, whether it is acidic or the alkaline, it will pass through our digestion systems and it will convert to that desired pH. Anyway, change. So it is not important that your product, what is the pH is, but what you need to find is that your product, whether it's how much effective or after absorptions, how much remain there. As I showed you data, that most of the polyphenol goes off. So that is the challenge. So it is important that to look into that aspects.
Okay, thank you, sir.
Okay.
Anybody also have any query? They can ask. Sir, I think so many questions were asked by participants. So now it's the time to switch off our program. So, sir, today we are really fortunate that you came here and joined with us for celebrating the World Nutrition Day program. And really, you have given very wonderful, very fantastic lecture. So definitely, sir, it will be very helpful to all of us. So I'm very much thankful to you, sir, on the behalf of director and all NRCG staff. So thankful, sir, very much thankful to you, as well as our director, sir, who have given us this opportunity and he has supported us to organize this program. So I'm very much thankful to our director, sir, Banerjee sir, as well as all of our staff, including AKMU unit, Kavita madam, Dr. Shabir sir, and all permanent and all not permanent staff also. So I am very much thankful to all of for participating in this program. Thanks to all of you. And I will declare that now the program is over.
It's my pleasure. Thank you very much.
Thank you, sir. Thank you.